Hi, Abhishek. Can you hear me? Hello, hi.
Hey Rajat, how are you?
I'm good. How are you?
Doing good, doing good.
Uh, shall I admit other people? I think there are eight of them waiting in the waiting
Yeah,
room.
yeah. I am joined on two machines because on my other machine, uh, the audio is not working. So I'll be talking on
Okay.
this and sharing the screen on the other.
No worries, it's fine.
Yeah. So in case, Rajat, if you are moderating, then whenever I'm taking some breaks, maybe every 5 or 10 minutes, if you can collect all the different questions which are there and then
Sure,
just give me a refined
sure,
version,
sure,
then I
sure.
will try to answer the questions. Yeah.
Yeah, definitely. That
Okay.
sounds good. Yeah.
I'm also sending a request to share my screen.
Yeah.
Did you get my request to share screen?
I've accepted it. You'll be
Okay,
able to
got it.
share the screen now.
Yes, yes, yes. I see it. Two.
Maybe we can wait for a minute more and then we'll get started.
Yeah, yeah, sure.
Okay, let's get started, everyone. Um, Everyone, it is my pleasure to welcome Abhishek to this sessions. I have been in touch with Abhishek for quite some time now, and he has been doing some excellent work in the overall field of AI with the intersection of reinforcement learning. So I thought his experience would be very valuable for this cohort because we have not seen any person who is working in a proper AI lab coming and speaking with us. So please feel free to share any doubts or any questions you have with him, and I hope you try to make this class as interactive as possible. And if you have any questions, directly ask them in the chat. Interact with Abhishek and get your doubts cleared. Please be more participative because he has told me that he'll be conducting this lecture in a more interactive manner. So uh, please make sure that you are more participative in this class. I'm sure it will be very helpful for all of you. So I'll hand it over to Abhishek now to continue the rest of the session.
Cool, cool. Thanks so much, Rajat, for the introduction. Hello, everyone. Uh, so in today's session, we are going to look at how do we do SWE training. Okay, so I'm hoping that every one of you is aware that SWE is now one of the most critical tasks, and I'm going into greater detail. I'm going to go into greater detail of what exactly we mean by this task and what all of this entails. First of all, I want to make sure that you guys understand the concept very well. This is a slightly advanced topic, right? And in case you have any questions, don't hesitate to ask, because it took me a lot of time to grasp, uh, to wrap my head around how to use RL in production, like how to use RL in a proper task end to end, while understanding all of these terms that keep floating around. Right? You'll hear terms like harness, agent, GRPO, rollouts, policies. And for a long time, like, I had a lot of confusion in my mind on what all of these different terms are. Uh, like, learning the theory is one aspect of it, but as I'm going through this class, the goal I want is that all of you should finish this class with a proper understanding of all of these terms and how they combine together for a realistic, like, production scenario. The way I'm going to structure this talk is that for the first 5 or 10 minutes, we will go into the task description itself. I'll show you a small example of the data set that we are working with. Then we will go into the overall picture that I want you guys to have in mind. If by the end of this lecture, you guys don't take away anything at all, at least you guys should remember this picture. Okay. Uh, Even if you don't understand anything or miss some concepts, this is a picture I want you guys to remember and keep going over and over in your mind. So we will go over this entire notebook together. Uh, that will take probably around 60 to 75 minutes. Then we will take a break. Uh, the second part of this lecture will be to go into a real production scenario of how we do the training, looking at some of the training dynamics, reward curves, how to do debugging in production, and yeah, that's the plan that I have for today. I also have this repo in case you guys want to keep running this notebook with me on your own side. I'll share it on the chat, and you guys will be able to execute it
Abhishek,
as well.
is it possible to zoom in? Maybe they are asking on the chat if you can zoom in or increase the screen resolution, maybe.
Yeah, I can zoom in for sure.
Okay, yeah, that would be very helpful. Thanks.
Is this good?
Yeah, this is much better. Yes.
Okay. And I've also shared the repo with you guys. So you can open it in Colab just like the way I have done, and keep running along with me. If you have any questions, if you hit any trouble, just ping in the chat. Sounds good? Okay. So let us get started. First of all, I'll show you one small example, okay, of just to set some background of what I mean by SWE training. So I have this file called temp.py. Okay, let me zoom in on this file also. Actually, yeah, this file is not that critical, but let's say that you have a file called temp.py and you have a similar test file for it called test_temp.py. This file is very simple. All it does is it implements a Fibonacci method, and there is a second function which implements a binary search. And then the test file has some test functions which go and test these two functions also. And typically, what will we do? So if we have this thing, right? If we have these two files, and I want to run, let me try to zoom in on this file also to help case. I never zoom in myself, so okay, zoom in. Is this better on this file also?
Yeah, this is much
Okay,
better.
you
Yes.
guys can see it, right?
Yes.
Very simple. So I have just defined a Fibonacci method, and then there is a binary search, and there is a corresponding test for the Fibonacci, and then there's a corresponding test for binary search. And then we want to run it. How do we run it? We just go in and we say PyTest, the name of the test file, right? And immediately I see that out of the two tests that we had, the test Fibonacci and test binary search, one failed and one passed. And typically, like as software engineers in this field, what do? We immediately open up Claude, right? And then ask, hey, why is my test failing? And maybe I'll paste in the name of the test file. And then Claude does something. So it goes in, it is hitting the backend model, which is Opus 4.8 in this case. It is going, and then it says, oh, your test Fibonacci fails and your test binary search passes because there is a typo in the recursive step of your temp file. And it has said what this problem is. And indeed, this is an intentional bug which I had introduced. The definition of Fibonacci is that Fn is equal to Fn minus 1 plus Fn minus 2. This is like a naive recursive implementation, not the optimized implementation. But here I had intentionally plugged in n minus 1 plus n minus 1. And then I say, okay, Claude, go ahead and fix it and rerun the test. Let me just say, go ahead and fix it. So immediately what we see is that Claude has gone and made this correction. Now, this is going to be the thing that we are exactly trying to build in this session, right? So what essentially has happened is that Claude has analyzed your file, and then it has gone ahead and suggested a diff. So this is essentially like called a diff. So it has suggested diff between your existing version of the code and the new version that it wants to implement. And he wants to make this suggestion, wants to make this fix. And then we go ahead and say, okay, accept it. And immediately now it says, okay, I have fixed temp.py. So I can go back to my prompt. I can go back to my cursor and then say PyTest test underscore temp.py. And I have seen that both of these two tests pass. So now the fundamental question is, how was Claude trained, or how was Opus trained so that it could understand that this is the fix that it needed? How did it know that it has to go into this file? Because I didn't tell him anything about going into this file. All I told him was that one of my test cases has failed. Please fix it. Claude knew that it has to maybe go and look into the open tabs here, analyze the function, and then suggest a diff. And this is exactly what is referred to as SWE agent, or a SWE model, a model that goes and knows how to understand code in a coding environment and go and suggest diffs that fix the user's problem. This is exactly what we are trying to go and build today. Okay. So let's come back to the notebook that we have. Are there any questions so far? No. Okay. Okay, so now let's go ahead and spend 5 or 10 minutes in understanding one example of an instance data set that we will try to walk through in this notebook. In the whole notebook, we will cover different things. We will first analyze a SWE bench task. So SWE bench verified is a very popular data set, which is used on the evaluation side of the world. For today, we will just use one example from it to go through this notebook. even though like technically we should not use the eval dataset for training, but for illustrative purposes, that is what we will do. Then we will cover aspects of environment. What is the environment that we are talking about, that in this case of SWE training? Uh, what is a SWE agent? We keep hearing this term all over the place. Like there's a SWE agent, there are papers which keep coming out about a SWE agent which has done well, increasingly well on coding tasks and so on and so forth. What is a SWE agent, and how is it a combination of both the model or the policy that we are optimizing for, and also the harness, which is the orchestrator or the infrastructure which does the loop for this agent. Then we will go into how we do some of the reward shaping. Um, Having done all of this, having understood what the environment is, what the SWE agent is, how we do reward shaping, finally, 5 and 6 go into the details of how to actually construct a group of rollouts that we can do, that we can use for the purpose of uh, GRPO training. Okay, so let me connect to my T4 instance. This is connecting. And for now, let's just run through the first 2 cells. Okay. So this is just some boilerplate that I'm installing at this moment. If you see, I'm also installing something called utils.py. This is a file that I have in my repo. I have tried to put all of the, I would say, boilerplate or distracting stuff inside utils.py so that this is all hidden away from you, so that we can focus more on the core of the material. But I'm just letting you guys know. And from utils, we have, for example, imported several of the methods like generate, sampler, rollouts, and all of these things. And Colab has given me this T4, so I have loaded up that as my device, which is a CUDA device. So let us go ahead and load one instance of this dataset. As I mentioned, we are going to use the SWE bench verified dataset. And in this case, what I'm doing is I'm loading one instance of the dataset, and I'm just displaying what are the different fields which are present in this dataset. Let's go and run this. Okay, let's try to understand what it is. Just one single row of the SWE-bench verified dataset. It has an instance ID. The instance ID is referring to a repo. In this case, this repo is called Astrophy, and it has a certain value. This value refers to pull request number. I will go into details of this. Then there is a base commit. Then there is, of course, this is the name of the repo. There is a base commit. Base commit is very, very critical when we are constructing the environment. Then there is a certain version and some metadata which is present. In terms of the different fields which are there, we have a problem statement. This is essentially the core of what is going to be the input for our training purposes. So the problem statement will be seen by the agent. You can ignore these terms if you don't know about it right now. It essentially has the GitHub issue that we are talking about. And then there are a bunch of things, for example, test patch, fail to pass, and pass to pass that are used by the grader. So I wanted to show you what I'm talking about so that you guys have a very concrete idea of what this repo is, what this commit is, and what this problem statement is. So I looked up on this Astrophy repo. This is open source on GitHub. If you recall, the number was 12907. 129, when I looked up 12907, this is 12907. This shows that someone has made a commit, uh, and he has committed a fix into main on the Astrophy repo. And when I look at, okay, what fix did he make? He made a fix in a file called separable.py. When I look at, let's say, the separable.py, it's only a one-line fix. Previously, this was set to equal to 1, and now it has been set to equal to right. So now try to connect the dots between what I showed you with Fibonacci versus what is going on in this example. In Fibonacci, the simple thing which we did was fib of n is equal to fib n minus 1 plus fib n minus 1. That was our bug. In this case, there is a similar bug, and it's a very simple fix, right? Uh, Someone has made this fix. This is from a long time ago, 4 years ago. And he has also added test cases. This is a test file called test underscore separable.py. He has also added some test cases to verify that his fix works. And it has been accepted into the main branch by the repo authors of Astrophy. When I look at, okay, why did he make this fix? You will see that in the conversation, it mentions that this fix is needed to fix this particular issue. I went and looked into the issue. And the issue has a very nice description. It says, okay, consider the following model, blah, blah. There is something wrong. And then this feels like a bug to me, but I might be missing something. So this was essentially someone reported this issue and then someone went ahead and fixed it. Now coming back to our collab, you will see the problem statement. Let's look at the problem statement. You see the problem statement that I talked about is exactly this. So he is saying modeling this, consider the following model. This feels like a bug to me, but I might be missing something. So essentially, the problem statement has been taken from GitHub's issues. Like as I have shown you, this is an exact verbatim copy of the issue. And then the other fields, which are patch and test patch, let's take a look at those as well. Let's look at test patch. So test patch is this div that we saw in this file called test underscore separable.py, right? You can see when we look at this file here, test separable.py, they have extracted this information and put it into a separate field called test patch. And similarly, there is something called patch as well. We will not go into the patch. The patch is essentially the reference solution. In this notebook, we don't use the reference solution at all, but this is essentially like the golden fix. There are two additional concepts called fail to pass and pass to pass. This essentially indicates that there was a test that was failing after the fix has been made. These test cases should go from a fail state to a pass state. So they must go from red to green, exactly like what we did in the Fibonacci case. Now, if you remember, I had shown this example. Initially, our Fibonacci test was failing and binary search was passing. So test Fibonacci would have been in the fail to pass example, and binary search, because it was already passing, would be in the pass to pass case. These become very important because when we try to make the fixes, we have to ensure that the failing tests move to green without regressing the passing tests, which must stay green. Let's look at those as well. If I look at the fail to pass in this case, there were two test cases that the person has introduced in this file test underscore separable. These are the fail to pass, and let's look at the pass to pass. There were essentially I believe, around 11 or 13. There are 13 test cases which should stay green, and then there are two test cases which should go from red to green. So with this, I will take a pause because by now we should have a good understanding of the data that we are dealing with before we go to understanding the next uh, picture here about the agent and the environment and the training. Are there any questions? Okay.
There is a question by Avinash who is asking that.
Mhm.
So these are basically sequential step by step of the model trace that is as a data set. Avinash, can you clarify this question once? It is a bit confusing to me as well what this question is essentially trying to say. Can you please clarify the question?
These are basically sequential step by step of the model trace as a data set. Uh, I think what Avinash is referring to is that there are some data sets where you get the entire trajectory of the model as a trace. In this case, we are not dealing with a data set like that. For example, there are some, so those kinds of data sets are used in SFT because then you will have already an entire data set which has been rolled through a model. Maybe you take a model like Kimi or Quen3, and it has gone through this entire trajectory and the whole data set is ready and you use it for training. Those kinds of data sets are mostly used for SFT purposes. In this case, all we are given is there's a there's a problem statement. Someone has reported it on GitHub that I think that this is a bug. And we have a reference example of what correct like uh, first of all, we know what the correct solution is, but we don't want to use it. This is the patch. The test patch is what the grader or the verifier should use to verify whether anyone who suggests a fix, whether it is a model or any other human being, the grader should use this to validate whether any proposed fix is right or wrong. That's all that we are given in this data set.
There is another question by Saurabh.
Mhm.
He says that we use Playwright and PyTest when we test our tasks, and once these are successful, the code is checked into Git.
Mhm. Yeah, so if you're using Playwright, I know Playwright gets used in some cases where uh, it is browser. It's mostly like browser related things, I believe. Uh, yeah, and PyTest, and they also have PyTests. You can certainly use that data that you have to train a SWE model like exactly that we are describing. Okay, Saurabh? So if you want to train a model specific to your scenario, which is Playwright, you can use your data. This is ideal data to use for SWE training because you already have your problem statement, which is identifying a bug. You have test cases that validate a proposed solution is right or wrong, and this is ideal data set for training a model for Playwright purposes that you are using. Are there other questions?
Uh, are there any other questions? I hope everyone has understood the overall premise of what we are trying to do. Yeah, I think people are typing
Okay,
yes. It's okay.
cool, 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 cool. Okay, so let's go to the thing that I was mentioning, that if at the end of the class today there are still some doubts or questions, I want you to come back to this figure over and over again to clarify your doubts. Because in my mind, this is a diagram that I have iterated over multiple times as I had questions myself, and that is how I have eventually landed on this. And there are some components to it. First of all, let me describe the components. And eventually we will end up coding each of them. We will code an environment, we will code an agent, we will code the reward, and then we will finally code up the entire GRPO loop as well. Okay, so in this class, you must have already talked about the agent environment interface. So what is the agent environment interface for the SWE task? The agent is, in my mind, a combination of the harness and the policy that we are trying to optimize. What is a harness? The harness is a loop which is doing all of the orchestration with the environment, with the rewards, and with the policy. Because at the end of the day, you need some sort of an orchestrator which is doing the orchestration between all of these different components. And this is what is referred to as the harness. Why do I say that the agent is a combination of the harness and the policy? The harness cannot do anything on its own. The harness needs constant interaction with a model. So it sends some context to the model. The context could be saying that, hey, I'm a user, I have this issue. Now the policy or the model sends a response, and that goes as in the form of an assistant role. So it suggests that, hey, I want you to go and execute a particular tool call. The harness is then responsible for sending it over into the environment where this particular tool call gets executed. So this is referred to as the action. So it will take an action in an environment. Um, the environment in the SWE case is a Docker container because we need to use a proper sandbox for running this tool call. You will get an observation back saying what was the outcome of this tool call. For example, here you could be saying that I want to run bash with some sort of ls or grep or some cat command, right, to make some changes in a file. So then you'll get an observations back saying that, okay, I was able to run it successfully. The reward code is 0 and the output is blah, blah, blah. Or in some cases, you were not able to execute that particular tool call in the environment, in which case the return code will say, okay, I failed. So it is a non-zero return code. And the output in that case is just blank or some sort of garbage or incomplete information. This comes back to the agent. The agent uses this information to send to essentially it comes back to the harness actually, because the harness is doing all of the orchestration. So the harness takes this observation, he passes it back to the model. The model looks at it and says, oh, the action which I took, it either passed or failed, and based on that I need to suggest the next action. So he will suggest an action back to the harness. The harness essentially has this increasing or growing transcript that it keeps producing. And then it will add it into its context and then send the next action or the next tool call back to the environment. And this keeps going on and on. So what are the exit criteria? The exit criteria could be that you either exit this loop when you have exceeded a certain number of max turns. This is often referred to as like the number of max turns that the agent has. Or there could be specific actions that are encoded to say that, oh, you think that you're ready, triggered the submit action, and the harness knows that submit action indicates that I should terminate this loop, and then this loop comes up. So typically there are also other constraints. For example, there's a certain context limit. In many of these models, it's either 32K, 128K. Sometimes there are also constraints like you can only do this for a certain period of time maybe 30 minutes or so. So yeah, this is what I refer to as the inner loop. Now, after you have done this, and based on the two exit criteria that you mentioned, either you have exceeded the number of turns or you have identified this sentinel action that indicates that you should terminate, the harness now needs to go and take a look at the entire uh, kind of what were the different diffs, or what were the kind of state which it has persisted inside this Docker environment. Potentially, that could be the patch that you are looking for, right? So it goes and again does the submitted patch apply onto this environment and then runs the test cases to see have you passed or failed. This is what is called as reward shaping. In this case, since I'm I'm almost indicating to you that this is like a test execution based reward. So it will be either a 0 or a 1. In some cases, it could be LLM as a judge, where after taking this diff, it makes the harness sends it to LLM as a judge as a verifier, which sends a reward back, and you use that as the reward thing. So now with all of these different ingredients which are there, you have the reward, you have this entire trajectory, so you know all the tokens which have gone into the assistant turns. These tokens will eventually be used for computing the log probes in the GRPO step. Once you have this, like the trajectory, you have the reward, you can now go over to do your the training step. In the training step, you have what I refer to as the outer loop. You have the trajectories, which are essentially the tokens, and we know what to mask and what not to mask. We have the reward. We can compute the grouped advantage, and we'll do a GRPO update. And once we do the GRPO update, this update is essentially on the same policy. We go and plug it back and say that, oh, now you are running a policy theta. Now it is, let's say, theta prime. This is loaded back, and now this new policy will drive the next further set of actions in training. This is what an entire training loop looks like. The way that I have described to you is what is referred to as on policy. In on policy, the concept is that we do like this policy, which has been loaded up and which is driving all of the assistant tool calls and everything. At this point, this is frozen, right? And it has done this entire rollout. When you do one update of GRPO, that is the point when you unfreeze the policy. You do your step of GRPO to update the weights of the model, and you then freeze it again and send it to VLLM for the next level of generation. So you can have all of the rollouts happening in async, but just before training, there is a sync step where you say that, okay, now I have done all of my rollouts. Let, let me now unfreeze the policy, do my model update, and take it back to the next level of rollouts. There's also another concept of async RL training, where you can do training and inference asynchronously. I would say that is a more advanced concept. For now, let us not go into that side. So this is, in this case that I'm describing, on policy GRPO update. There is one question which I would like to ask you guys at this point. The way that I have described this is, as I mentioned, for training, right? Because I've described that this will be the agent environment interface. Which parts do you think get exercised at the point of inference? So which of these blocks get exercised when we did this example of running Claude to answer our question? So If you can just tell me which of these blocks, agent, environment, reward, GRPO, which of these got used when we were doing the inferencing step for solving our problem?
There are some answers coming up, Abhishek. People are mostly saying
Yeah.
agent, agent, agent. Everyone is saying agent.
Okay. Okay. Someone is saying agent, action, environment.
Someone is saying policy also.
Okay. Yeah. So yeah, this is why I wanted to ask this question because these are nuances which were not clear to me as a student myself. And I would come out of a class and think that, okay, I think I have understood what is going on. But I would say most of the answers here are wrong, okay, except for maybe someone who said agent, action, environment. In the case where I showed this example, right? Like I gave these two files. I opened these two files and I gave this repo and I asked Claude, um, if you recall, I asked Claude, what was the test case that was failing? What is Claude here? Claude is nothing but this harness. Okay? Claude is nothing but this harness. It is purely just a engineering artifact that you have launched on your machine. Claude by itself doesn't have any brains. It if it is disconnected from the internet, that's why Claude doesn't work when your internet connectivity is gone. If I take out the internet from my machine right now, Claude will not be able to answer this question because it's purely an engineering block which is running on your machine. Claude is just this harness. What is driving Claude to find this answer? It is the opus, the model. Okay, that is the model that Anthropic trained. There could be many other models, like GPT has its own models that it has trained. Now, clearly these two components are in play, right? Are you guys following me? Claude is just this harness. Opus or any other model like GPT, GPT Soul, GPT 5.4, GPT 5.5 is this policy which is driving the harness. But now, can you tell me, is this agent sufficient to answer my question? Can you tell me in the chat? Yeah, someone is saying no. Is there anyone who is saying yes? Okay, so the consensus is no. Yeah, no is the correct answer because if I don't give Claude the repo or the context that I'm working with, so let me go back here. If Claude doesn't know that I'm supposed to work with these files and then there's a temp.py file that I need to update, then it cannot do anything, right? But if I delete this temp.py and I just run test underscore temp, it won't be able to do anything. So this repo in our case is the environment. Okay. So Claude takes multiple actions. Maybe it has done an internal action to go and do a ls command to first understand what are the different files which are there in this repo. It has seen that, oh, there is a file called temp.py. So this is the observation which came back. If there are some tools where you can go and look into the internal actions which Claude took to finally come out with this answer. And we will go into the depths of that when I show you the training. So it will become very, very concrete. But our environment is this repo that we are working with. And Claude, with the help of its model, which is Opus 4.8, has done multiple iterations over your environment, which is this repo, to finally go and figure out, oh, like there are so many of these files. He is referring to this temp.py file. Then it has opened up this file to understand its entire contents. It has figured out that there was a bug here at this point, and then finally went and suggested this fix, n minus 2. Okay. So at the point of inference, now coming back to my original question, at the point of inference, can you now tell me which were the blocks which are involved in finally answering this question which I had? Chat, can you answer my question? Which of these components played a role at inference time? Okay, agent and environment. Okay, cool. I think now you are getting most of you guys are getting the answer correctly. Now, essentially, it's a combination of the agent, which is the harness and the policy, and the environment, and the way it got to this final inference solution is by taking multiple actions, looking at the observations, and essentially this green block here, this blue block here, and these arrows which are going back and forth is what happens at inference time. Okay. Reward, GRPO, all of these things come only on, yeah, Samantha has said that essentially the inner loop, exactly. The inner loop is what is going on at inference time. This outer loop, which I talked about, which is this line coming to the reward, going to the outer loop of trajectory, doing GRPO update. This outer loop happened only for training purposes. So I think that is one thing that you guys have now
Abhishek,
internalized.
there was a question by Shriharsha a while back. He's saying that for each of the 16 rollouts, will you be running them on 16 separate Docker containers in parallel?
Yes, yes, exactly. We cannot run these 16 different rollouts on the same container because it will lead to corruption. If on the same container I have a rollout going and it has made a change to a file, let's say it tried out a change saying Fibonacci n minus 4. And then there is another rollout which came and said, oh, now I want to do Fibonacci n minus 5. There will be corruption in this case. So all of these run in isolated environments. We will also see it when we do our own training. Maybe optimize using Git worktree. Yes, Git worktree is another option. So because I'm talking about Docker containers can be easily spun up, and all of these will ensure that there is isolation. Git worktree is another way to do the isolation. The problem with, in fact, when I was implementing this suite training, Git worktree is something that I had explored. There are pros and cons of using Git worktree. We can go into depths of that as well. I'm very happy to answer that question. Docker is inherently a bit heavy, but lots and lots of open source datasets will publish the Docker containers. Okay. Git worktree, nobody is able to publish it because Git worktree sits on your machine. There is no way to replicate this in a realistic setting. So that is why generally Git worktree is not there. But if it is your own data set, then certainly yeah, Git worktree is a way to isolate the different environments during training. Sita has asked the question, why you pick GRPO? Uh, Why GRPO and not PPO? That's a good question. GRPO is essentially shown to be more stable than PPO. Previously, I have also had some experience with PPO, but you end up loading a value network, which essentially creates more memory consumption on the GPU. And very hard to train in practice. So not to say that it is not useful. There are some specific scenarios where PPO is useful. But yeah, between PPO and GRPO, at least for suite training, for this discussion, we will use GRPO. And yeah, PPO yeah, will end up having 3 or 4 different copies based on how you optimize it. As far as DPO is concerned, I would keep DPO completely out of this particular formalism. Because for DPO, you need two, for a particular question, you need two pairs of solutions. One pair which said that this is the accepted answer, and the other which is the rejected answer. And DPO fundamentally works by trying to draw this distinction between what is the right answer and what is the wrong answer. So it is more of I would say, a data set constraint problem. And some people don't even consider DPO to be real RL because it is more, DPO was very popular. It works in some cases, but not for SWE training. Yeah, verifiable rewards. Yeah, in this case, like I had mentioned, we are using test case execution as our rewards. We can use LLM judge as a reward. Typically for SWE training in production, judge rewards are not very good because there are multiple ways to write code. Okay, like even for the Fibonacci example, which I talked about, this is not the only answer that is possible, right? This is not the only answer that is possible. What if Claude had given me a saying, correct corrected by doing the iterative Fibonacci. See, this is this is also a perfectly valid implementation of Fibonacci. Instead of doing the recursive solution, it has now done it in an iterative fashion with a for loop, looking at the previous and the next, and then so there are multiple ways to write code to come up with the right answer, which will pass your test cases. And LLM as a judge often fails to find this distinction because it is very nuanced. So in SWE training, we typically go for execution-based reward because there it is clear. You have suggested me some code. This code either passes my test cases or not. You can add in additional factors of complexity. For example, what was the asymptotics of your solution? And based on that, you can, yeah, did you suggest me a O of n solution or a O of n square solution or exponential solution? So those can come in into your reward shaping. But fundamentally, if you rely on execution-based rewards, that is what is mostly followed in practice. Shall we move ahead? Do you give reward for partial test passes or is it 0 or 1? It's a very interesting question. Uh, I'll tell some audience why this is a very interesting question, because if we just rely on binary, which is 0 and 1, then in GRPO training, you may end up with a scenario where your these rewards are very sparse. So let's say in a GRPO, you will have uh, a certain number of group size. Maybe for each problem, you have asked 8 solutions for it, and it is not able to get to a solution in any of those 8 rollouts, in which case all of those will be 0. And essentially that entire group size will be wasted. So in those cases, we can follow this approach where we give some reward for partial test passes, and then say I may do a hand wavy thing and then say that, okay, I will give you a 0.1 if you pass n number of test cases. Uh, yeah, those fall into the area of reward shaping. It's a extremely critical piece of how you ensure that you are training in a proper way without losing your rollouts. And also it becomes important in reward hacking because in some examples, the model will start to reward hack. But to answer your question, do you give reward for partial test passes? In this case, for today, no, we will do only 0 and 1. In practice, it is done.
Namrata
How
has a
can we
question. How can we make it self-improving? SWE agent, is GRPO alone sufficient for that?
What do you mean by self-improving?
Yeah, maybe
Uh,
if we have any bugs on a website, like let's say, and
mhm.
a user clicked on it and we want to improve that website or uh, yeah, something like that. Like it gets improved automatically on its own whenever there are bugs.
Yeah, there is, see, at the end of the day, it's very hard to say uh, that it is self-improving. You do have to, you you do see, you have deployed this policy into production. And this policy is what is driving all of your behavior right now, let's say. Even if you talk about self-improvement and you have plugged in this entire training loop, at some point you have to check mark a particular policy, then go and do offline evals before you go and make a deployment to production. So even, for example, companies like Anthropic, like this is a general like ML concept, right? So if you have a scenario where it is being driven by a machine learning model, it is very dangerous to say that I will update the model on the fly, because if you update the model on the fly, bad things can happen. You do want to do some sort of offline evaluation, offline checks, offline analysis before updating your model into production. Not to say that it cannot be done. Cursor has published a blog post a few months ago where they say that, oh, we update the model on the fly, and we do RL on the fly. So it is possible, but those require a lot more engineering infrastructure behind the scenes beyond the traditional training loop. Does
Got
that
it.
answer the
Thank you.
question?
Yeah,
Yeah.
thank you.
Few steps. Okay. What the hell? Okay. Yeah, traceability becomes very important in the self-improving loop. Yeah, but it becomes a question of how trustworthy do you think your self-improvement is before you deploy it into production? Yeah, self-improving is also a policy update. Yeah, let's not go into too much semantics of self-improving for now. Let's just stick to this mental model and mental map of how the training goes on. There is training and improvement going on in this loop itself. So we'll try to fix this in our minds before going to other more advanced concepts. Okay, so we'll move ahead if everyone is clear on this. But I wanted to spend at least the time that we spent because this will come to this picture again and again. Okay, let's go to the environment. I already described briefly. In a real production setting, it would be Docker containers. We will have maybe isolated Docker containers where the state is changing. But first, let's understand what we mean by a state here. So the environment has some state, which is that it has some files which have been checked out at a particular base commit, because that bug that we were talking about happens only at a particular commit, right? And we know that it happened at that commit, so I know the state of the files at that commit. Maybe it has been fixed, so commits have gone ahead into the future. So we need to know exactly at what point of time the bug had happened. Anytime we are taking an action, the state has moved from state to state prime. And along with that, it has produced an observation. So the action in our case is a bash command. It could be an ls or a grep or cd. These are kinds of states where the files remain the same. There have been no modification in the file itself. You are just making different observations about the state. But there could be other commands like cat, where you go and cat some blah blah into a particular file, and you have essentially ended up modifying the state itself or the files themselves. So this essentially encompasses what an environment for us is. Yeah. So let's run this cell now. So here I have created a mock environment, taking the fail to pass that blurb. And let's see what we have here. Okay, so what is the state that we are working with in this particular notebook? It is one specific file in our environment. So if you go back, our environment was essentially this entire repo, astrophy, blah, blah, at that particular commit. And just to keep things simple, we are only working with one file, in this case, the separable.py. At this point in the state, it has the bug. If you remember, this was the final bug that we need to fix. If you recall this, this is the bug, right? And we have taken out this to be our state. So our initial state has this bug. And the question is, after doing some training, can we train our model to do things correctly? But yeah, at this point, this is our state. Okay, we take different actions in that state. Here I'm just going over the conceptual parts of it. There could be different actions that we take in our state. For example, it could be an ls, it could be a grep, it could be a Python PyTest, it could be a cat where we make some particular addition into our target file. So let's run this just to get a sense of how, when taking different actions, we modify the state. Okay, so here I'm showing that if you take actions like ls, has it made any modification into the files? No. Uh, what has the agent observed after running this? Whatever output came back. ls is for listing the state of a particular folder. So here the observation is what were the different files in the repo at that point of time. Then you can do a grep. It is looking for C write. Okay, it showed that at line number 24, there is some line here. Then Python, it tried to run. There could be an action like Python PyTest. Here I'm saying failed because I don't, I have not allowed running PyTest in my list of allowed tools. I've only allowed a few things like grep, ls, and cat just for the sake of this notebook. And then you can do a cat with something, and this essentially tells you that, okay, I have written some files. I have written some lines into this file. If you do all of this and you ran these different things, and then we can look at the new state. Okay, what happened to what does our new state look like in this world? Okay, here, because I knew what the solution is and I know what the candidate patch is, I know there is some way for me to go and fix this. Okay, now the state has, because I knew that what the correct solution is, I can easily move from a state where it was equal to 1 to a final state where it is equal to right. But I'm doing this just for illustrative purposes. And then I have also showed you what is the patch that the environment has. Because if you remember, coming back to this diagram, after you take all of these different actions, you will need to have a patch that we need to apply back into a cleaned version of the container to run the tests. So this is what I'm trying to show here, that after taking different actions, you are ending up with some final state. And in that, if you compare the diff between the initial state and the new state, you can get a patch, and the harness will try to go and plug in this into the environment and then run the verifier to see whether this patch solves your test cases or not. Is this clear? Before we move ahead to the agent, I want to make sure that conceptually we are all clear about what the environment is, and in this case, how we take multiple actions into the environment to finally get to a patch. Okay. Aman has asked the question, many people are clear. How we define choose actions for a particular use case. Suppose my environment included the Git repo, Jira Workspace, and some other DBs. Is there a guideline to pick only the most relevant versus all action tools? Yeah, that's a good question, Aman. I don't know if you have heard of something called the mini SWE agent. So you can look it up. You can do a lot of things by just using bash. So you can say that the only tool I have available is bash. And what commands you run inside that bash, you can have a knob on that. You can say that I allow you to go and do ls grep cat blah blah blah, but don't do rm-rf, because that is going to be a completely destructive operation which can potentially delete all the different files, right? So in terms of tools, you can say, yeah, you can say I can just do bash as a tool, which is what many of the, even some of the best training agents use just bash as a tool. But at the same time, what Srihara is saying, that is also correct. In the system prompt, you can define what are the different tools that I have given you access to. So for example, you can say that I have defined a specific tool called read file. I've defined a specific tool called write file. I've defined a specific tool called edit file, or something like that. And then you can specify it in the system prompt. And then this harness, which has read the system prompt at this point of time, at the point of initialization, it knows that these are the only tools that are at my disposal, and these are the only ones that I can use to drive this behavior. Also, we can use RAG for tools to dynamically load tools based on the user query. Yeah, yeah. So there is also this entire body of literature for tool discovery. I think what you're referring to is in literature referred to as tool discovery. Your your harness can look up another system, let's call it a retrieval system, to figure out what are the tools at my disposal that I can use to drive this behavior. Again, this is maybe a slightly extraneous concept. We'll not go over it. In this case, we are only using one tool, the bash tool. I have limited the commands which you can run inside bash. And even in like production settings that I will show you in the second phase, I'll show you how this is such a powerful way. And yeah. Does that answer your question, Aman? Hopefully it does. Is there a guideline to pick only the most relevant versus all action tools? I don't think there is any particular guideline. You'll have to uh, pick and try. During inference, if the entire code base is present in context, are there actions like only for compilation and verifying answer we need environment? Basically, we are not loading the code base in context. Yes, in fact, that's the whole reason. What you are saying, if the entire code base is present in context, it is not present in context. So the question from Karthik is, during inference, if the entire code base is present in context, are actions like grep ls needed? I would say that the premise that initial if statement is incorrect. The entire code base is not present in context, because if the entire code base was present in context, there would be no need to do all of these different actions. And keeping that entire code base in context would have already blown up the KV that is needed. So that is the whole reason why you only do piecemeal stuff based on what the model is telling you. If the model is telling you, go and look at a particular file, this is the model telling you, it goes and looks at that particular file and brings that information into its context. And that is why context keeps growing, but only to a certain extent. If it had loaded up the entire thing in context, it would have exceeded all of this stuff immediately and blown up, and you'd be hitting compaction issues over and over. And each command would be a tool, right? So there is a distinction between command and tool. Uh, Maybe a slightly more advanced thing. Your tool could take commands as arguments, and you can define it that way. For example, you can say that I have a bash tool. The bash tool, let's say def function bash, it takes some arguments. The arguments could be the commands that you want to run, and you can define it that way. On the other hand, you can define a completely separate tool which says read file. Now it's a separate tool altogether. Okay. And you can do the orchestration that way. So each command would be a tool. Well, yeah, possible if you define it like that in the system prompt. But for the purposes of today's lecture, and also I would say not most cases, I would say limited settings, you go with bash as a tool. You don't try to blow up the tool space, at least for SWE training. Just to confirm, the agent in the project you are demonstrating doesn't have access to any tests, right? To avoid, yes, that is true. The agent, the agent doesn't have access to any of the test cases. It doesn't see any of this. In fact, you have to hide it, because exactly like what you're mentioning, it can try to reward hack, it can try to look up the test cases to suggest the changes that you are making into this loop. So even when you have a Docker container where you have all the files there, the test case files are kept out of the Docker container. They are kept out of the environment so that it cannot see it. Only the verifier has access to the test files, because the verifier and the harness will get hooked up with the verifier to run the tests. But the agent or the policy, like this part, should not see the test cases at all. Cool. Cool. Yeah. Thanks a lot for asking these questions, by the way. It's very useful for me as an instructor also to understand how maybe some concepts might have been missed as I'm explaining. Okay, now let's go to the agent. So what have we done so far? We have covered the training part, we have covered the environment. Now let's cover the agent, which will be the harness and the policy. And then the final pieces will be the reward and GRPO. So the agent. So I have kind of alluded to briefly. In my mind, the agent is a combination of the model and the harness. The model is the policy that we are using. It could be Opus, it could be Quen 314 billion. It's completely stateless. There is just a input in, which is what are the different messages you have seen so far and the observations so far, and what do you think is the next thing that I want to do? Typically, what you will invoke by using model.generate, right? That is our model. And then we have the harness. The harness is purely deterministic code. It is purely an abstraction for it's an engineering abstraction. It knows how to prepare, parse, execute, append, all of these different cases needed for orchestration. The harness doesn't have any notion of weights, or like it's like don't even worry about training or anything. Both of these are very, very critical. It has been, some people end up making the mistake of just optimizing the model because they think, oh, like it's fancy. I'm here for doing machine learning and I want to do some training. So we'll just keep on improving the model and that's it. No, a lot of the recent work has focused on harness, how harness improvements play a very critical role. If you have been following some of the recent posts from Anthropic, OpenAI, they have all said that they have gotten 10, 20, 30 point improvement on benchmarks by improving the harness. They have entire engineering teams dedicated to improving the harness. And the harness is essentially what does then this entire loop, the system prompt, the compaction, like making choices, when to stop and not to stop, and those kinds of things. And both of this combination forms the mental model of the agent that we are talking about. Okay, we are also talking about rollout. I think you guys are already familiar now that when we have this model with the harness driving it, this entire thing all the way uh, till we either exhaust the max number of turns or we get a patch is one rollout. Just a definition here. Okay, so for this notebook, we'll just use Qwen 2.5 coder 0.5b instruct as our model. Here I have just loaded it up. In case you guys are also running it, you can run it at this point of time. And let's see what are the different things it. So what am I printing here? I'm just printing the model and how many parameters it has. This is 0.5 billion parameters, so that's why we see around 0.5. Okay. I've just loaded up the model. We have been talking about the harness. In short, the harness is just these 4 different loops. I mean, these 4 different steps. You have a for loop going up to a maximum number of turns. You got the initial context, which is the system prompt. Many people have already identified that the system prompt will have information about the tools. The issue, which is the problem statement. So that is your initialization of the context. You prepare this by passing it through the chat template for the model. Then you call the model. So you invoke the policy. So I'm in my mental map. This is the part I'm talking about, the agent. Okay, there is a for loop here. So in our for loop, this is what is going on. We have initialized the context. Then we make a call to the policy, that is the model.generate. Okay, then we will pass it to the environment and then we'll get the observation back. That is what I'm showing here. So we call model.generate. The policy has given us a reply. We now parse the reply to see what is the action that the model is asking me to take. This action could be, we have seen it already. It could be ls, it could be grep, it could be cat, it could be something. Maybe it is nothing. You can say that, okay, if the action is none, this is my second criteria for breaking out. The first criteria is this itself. Or you can define your own criteria. What is your criteria for breaking out? If you say my action is equal to submit and break, that could be another one. So assuming you have an action and the action is valid, you call environment.run. So you have passed it to the environment. You are asking the environment to run that action. You get the observation back. Now that you have the observation, you append it to your context. So whatever was the running context that you had, you now add the model's answer, the model's suggestion, and the observation from the environment. You add it to the context, and you go back to the for loop. So, and eventually whatever is the thing that you get is what is referred to as a rollout. Conceptually, this is simplistically all that the harness is doing. So let's try to run it. Here, this is the exact same pseudocode in code. So this is a run agent. It has taken the model, the tokenizer. We have defined max number of turns. We have a temperature setting because you need to pass it to model.generate. Initialized with the context. So it was a system prompt which had some information, then a user prompt which describes the problem statement. And then we have this for loop where we do exactly the same thing. We get the prompt, we get the reply, we get the action, and then we add the context. So any reason to choose Quinn for this purpose? No, just because it runs easily on the notebook and on a T4 instance. Yeah. So I've run this. So let's see what it looks like, right? Because I've only defined it. We'll try to run it. What does a SWE rollout look like with the model that we loaded? Let's see what it looks like. So now in your mind, you should remember what I have made one invocation of the run agent and I have got an entire rollout, which is the trajectory. So let's see what it had. Let's go over it one by one. The first was the setup part. It had the system prompt, the harness wrote the system prompt. I'm just displaying the entire rollout that happened, where it's, oh, you are a software engineering agent, you are in a Python repository, fix the bug described, blah, blah, blah. I've just given a small preview. And then this corresponds to this line, okay? This is the system. I have given the system message. And then there's a user with some content and the issue. It is this line here. The user has said, this is my issue. I'm modeling separability metrics does not compute something, blah, 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 blah. This was exactly the PR description here. Consider the following modeling separability does not compute. I think it has also included the heading and then the issue description. So this was the heading followed by the issue description. So these two lines, system and user, are set up here. Now we go into the for loop. There were 4 turns max. So these are the 4 turns, 0, 1, 2, and 3. This goes and hits the assistant. This goes and hits the model, basically. The model is suggesting go and run this command. Go and do a bash. Your arguments should be ls, grep, and blah, 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 blah. The harness has parsed it. That is the role of the harness. It has parsed all of this information. It sent it to the environment. The environment ran all of these commands, got this observation back, and it has added that information as a user role. This is exactly this line. So we first got something from the model, the harness parsed it, it ran it in the environment, and went and added the observation as a user role. Okay. Now, in the second turn, after it got all of this information, the model saying, oh, I want to run a bash command with python setup.py install it. Look at this. It is doing something which I would say is quite dangerous. It is going to go and install a setup.py file. Now, if you recall, in my case, I have restricted that you are not supposed to go and install anything. You only have a handful of commands at your disposal. And hence, when it goes and tries to mark with this environment correctly, it says, okay, I'm not allowed to do it. I only have access to ls, get, grep, pytest, and some of these things. Now the model didn't listen to this message. It went and tried to do a pip install this time. Again, it got blocked. It said, okay, now I'm not allowing you to do a pip command. I only have, again, I only have this. You either use this, I'm not going to allow you to do anything. The model, because it's a 5 billion parameter model, it goes and tries to do the setup.py install again. And again, the environment is saying, no, I'm not allowing you to do this. Our max turns run out, and this is the end of one rollup. So in this case, what is the candidate patch? Essentially nothing, because it tried to spend so many of these turns in trying to maybe first understand these files, but it didn't really do anything meaningful. So your candidate patch is empty. So this is an example where you should get a reward of 0. Now assume that there was an Oracle model. I'm doing this purely for illustrative purposes. I've hard coded it. What would the Oracle model have done? Let's try to run the exact same thing. And actually, maybe before running, I should have asked this question. And Oracle, actually, let me not show you the answer. What do you think Oracle model would do? Chat, can you answer? So an expert model, which knows exactly how to find the solution, what do you think its rollout will look like? Can you guys answer in the chat?
Can everyone answer in the chat, please?
Okay. Samita has answered. It should first read the file and then update the file at the exact line. Yeah, that's the right answer. So yeah, it does something. It could do ls grep, do something. And then essentially, because it is Oracle, it already knows what is the right thing to do. You will see here it tries to do a cat of the file exactly where the bug is, and then it tries to do a cat exactly on that, right? And then um, try to run the test. It also tried to run the test, by the way, and then it failed. Because it is not supposed to run that. I mean, you can allow running of the tests, but in this case, I have not given that ability. And then check the tree saying, okay, what are the different files? Do I add anything else? No, my turns, I have exhausted the number of turns, and then I have the correct patch. So essentially it has fixed this from 1 to right. Virendra has answered, it will use the exploration technique on all the commands and then keep on exploiting one of the command. No, Virendra, essentially what I was asking is, what will an Oracle model do for the rollup? An Oracle model is, let's say, someone that knows precisely the answer to this specific question. So coming back to the Fibonacci example. So let's say I had this bug, right? And at the point of I'm asking a rollout to tell me exactly how to fix this bug. Or the bug was that, okay, I should have updated from 1 to 2, right? So essentially it would have said, okay, look up this file, temp.py, and immediately make a fix from 1 to 2. Don't even look at other files, don't do anything, just look up this file, make a cat and fix it. So that is essentially the concept that I'm trying to drive here. When I'm talking about the agent with the model and the harness and the rollouts that you get, because essentially these rollouts are what we will need for training at the end of the day. So that is the concept that I was trying to drive at. Is it clear? Hopefully it is clear to everyone. Okay, cool. So these are the rollouts. Now, you guys will already appreciate something here. We have two rollouts. One rollout which didn't give me the patch, and another rollout which gave me the exact patch. Okay. We want to use these. At the end of the day, these are the rollouts that we want to do for RL training, right? So if there is something which didn't give me a patch, it should get a reward of 0. If I got a rollout which gave me the absolutely correct patch, which solves the test cases, it should get a reward of 1. And these intermediate things, these intermediate tokens or these turns, like system, user, assistant, user, these are essentially used in the training process. Specifically, in RL training, we will use the assistant role, because this is the learning information that you are getting in RL. Like what was the assistant telling you? Because what the assistant told you led to the final outcome, which was the correct patch. So these are the correct actions that the model, the assistant tokens are essentially the correct actions which led to the answer. So when we do a log prop over the action tokens, we are taking the log prop over the assistant tokens. Similarly, in this case, when we did not get to the right patch or we got a reward of 0, we should be penalizing, or we should be driving the reward for the, we should be driving the log probes for the assistant tokens down, because they eventually did not lead to the correct answer. So this sequence of things like bash, ls, and all the tokens involved here, all of these things repeating, and again, not this one, sorry, like this one, and then repeating again, and then repeating again. All of these are the assistant tokens, the actions taken, and they should be penalized for not getting to an answer. But things like this, where it says read a file, where it read the correct file, and it also knew that I need to make this particular change in the file. These are essentially the tokens coming from the assistant, which should be boosted up in training. That is the whole concept of reward and GRPO that we are going to focus on next. Before I go to reward and GRPO, is this part clear? Is our agent more like a bug fixing SWE, or prompts like build a basic snake game? It has to generate whole repository source code with unit tests. In that case, verifying will become, because model may write weak tests and generate. So Karthik, let me answer your question. The agent that we are building is a SWE agent. The way we have trained it is by training it to fix bugs. But fixing bugs is the most primary thing you can do to also write entire source code, because fundamentally there is no difference between making one line of code change to fix a bug versus writing 10 lines to fix a bug versus writing an entire repository where you're writing multiple files. Okay, so because this is the primary case. That is why we are using it for, I mean, most people use it for training purposes. Oh, sorry, that question was by Karthik. Okay. Yeah. So bug fixing is, I would say, the fundamental thing they use for SWE. It can be scaled up to write entire repositories. Yeah. Are we using Echo, Vishnu? That is a question. Right. In this case, we are not using Echo. We are purely using only the, we are using purely the assistant and specifically the assistant tokens. This is what we will be using for our loss formulation. Echo, if some people are aware, Echo is essentially saying that we are completely throwing away the information that we are getting from the environment. For example, in this case, the environment gave us this information that we wrote 29 lines to this file. Or in this case, there was some feedback from the environment which said that the environment is not allowing me to do this, right? So this feedback was never used, or it was kind of masked out in the loss objective for RL, but potentially it could be used for modeling the world or modeling the environment that the agent is operating upon. And Echo builds on this principle where you say that, okay, let me somehow try to make use of the environment in my modeling process. That is what Echo is all about. But in this case, and Echo simply does in the loss term, there is another term that comes from using the environment information from the user roles. In this case, we are not using that. Okay, Namrata has asked, so for training, we mask user tokens and consider only assistant tokens. How are we penalizing user tokens for not getting to answer? Yeah, Namrata, that is the right mental map. We in this case we will mask out the user tokens. We will consider only the assistant tokens because the assistant tokens, when shaped in the right way, gave us the reward. We are not penalizing user tokens for not, yeah, user tokens are things that like even for, let's say, SFT, right? The user could have been leading you astray also. So it's a fundamental question. Do you want to use user tokens or not? Things like echo, where feedback is coming from the environment, needs to be thought of in a different way. But fundamentally come back to this thing here, to this diagram. The policy, right? The policy was recommending these assistant tool call messages. And these green lines are what got executed and got an observation back. So fundamentally, whatever the model was telling you either got to a reward or didn't get to a reward. So you should be using these for training. And whatever the user, which is essentially the tool response, is just an observation that you're making about the environment. So you can safely say that, okay, in my RL objective, the tool responses are not playing a big role, so I can ignore those. And echo is one way of leveraging tool responses also to model the environment, but let's not go there. How are we penalizing user tokens? No, user tokens are just observation tokens coming from the environment. Is that okay? Hopefully that concept is clear now. Oh, cool. By the way, these are very good questions, honestly, because when I was going through like RL in some of my initial courses, these things had gone over my head. I'm really impressed by all the different questions that you guys are asking me. Okay, so let's go to the reward. Now, after getting, let's say we have done this entire rollout, the rollout is either giving us a patch or not giving us a patch. We have to run it through a clean state of the Docker once again uh, to see whether it passed the test cases or not. Here, it's very hard to spin up a Docker, especially inside a notebook environment. Cool, cool. Yeah, Professor Rajat is really good. I took his course as well, so he certainly helped in me understanding a lot of these concepts. There's a question about echo, but I'm not gonna try to even answer that. I think we have a lot of material to cover here, so let's move ahead. Reward random. So I'm basically saying that if you have not been able to produce a patch, give a 0. If you did produce a patch, I will give you a random reward. Because just purely because it's very hard in a notebook to run it through a verifier, specifically a real verifier. So this is the reward I'm defining. Okay, now we come to sampling and taking GRPO steps. This should be, I would say, relatively straightforward. So one of the main things in GRPO is that for the given problem, we have to sample it G number of times. For all of those G number of times, we need to get the reward, right? And that is what this loop is doing. So we have defined G, then we are running it through the agent each time, getting our rollout. Now I'm passing that rollout and its patch to my reward function. I'm adding it to this list called group, correspondingly the reward. And just for a reference, I've also added the expert as an additional rollout. And let's run it to see what we get. Now see, while this runs, I want to highlight some interesting things that was asked in the chat. For every for loop, we are calling the run agent. And what did the run agent do? The run agent, if you recall, was creating the environment. Now, do you recall there was a question in the group where they asked, do you create isolated Docker containers for each of the rollouts? This is exactly what is happening here. I have now, if you think that my mock environment is like a Docker container, I am running it each time in a loop, and in each of the run agents, I'm creating a completely new instantiation of that environment in which under which all of this is being run. I think this was a very interesting question and is completely being answered by the code here itself. So for each of these, we are running the agent. The agent is going and creating an instantiation of the environment, doing everything in there, and then giving us the final rollout that we score, we append to the group, we compute the reward, and that's how we are progressing. This is purely inferencing going on at this point of time. This is purely inferencing and verification going on at this point of time. So essentially, the green block, the environment block, and the reward block. These are the 3 blocks which are going on when we are doing this step of the process. And I had defined G to be 8. I ran it, first of all, 7 times to show the actual thing. You will see that in the 0, 1, in rollout number 2, it created a patch and it got a reward. And of course, in the last one, it should be G minus 1. In the last one was the Oracle also, which I plugged in as a reference example, and it also got a random reward. So essentially from 0 to 7, only 2 of them created patches and got non-zero rewards, and the rest were not able to produce a patch and they got 0 rewards. Okay. So now with this, we go to the final step of GRPO, where now we will talk about this part of the story. Now we have collected all of our rollouts. We have now got our reward. We now have to do this GRPO update step on the policy and then feed the policy back. So before I go to the GRPO, are there any questions on this sampling part, how the rollouts happen? Any questions?
Can you comment yes on the chat if you are understanding everything that have been covered so far?
Okay, perfect.
Yeah.
I love seeing so many yes.
Yeah, I think they are finding the explanations very clear since you are going through the depths of all the individual little things. Yeah, I think
Okay,
you
cool.
explained with a lot of clarity.
Okay, cool. Yeah, thank you. Okay, so now we'll go to the final block. We'll take one GRPO step. Fundamentally, this is so if you recall, the gradient of the performance measure is the advantage multiplied by the log props. And yeah, you take some mean and all of those things. So first, what is the advantage? The advantage for each of these is computed by taking the reward that you got and how much it deviates from the mean. So in our case, we have gotten all of these rewards for the difference. So we will compute the mean. And for each of them, we will subtract the reward from the mean and then compute the advantage for each of them. This is, this is essentially what we will do. There's a subtlety here of why I loaded the model in LoRa. Maybe you don't have to go inside this. This is purely because I was hitting some issue in doing everything loaded up as the full model in FP16. When I use LoRa, then only the adapter weights are in FP32 and it helps me run in a notebook. So ignore this cell. I'll just run it and you guys can also run it. But essentially LoRa will reduce the number of trainable parameters to, in this case, around 20%. But let's keep this in mind about how we compute the advantages. And I'll run this cell a bit later, but let's go this. So we had all of our rewards, right? So if you recall, what were our rewards? I can just do rent rewards. Oops, sorry, reward. These were the rewards that we got, right? Several of them were zeros and 2 of them were 0.637 and 0.27. This is exactly what it is. And then I compute the advantage by just implementing this equation here. Each reward minus the mean divided by the standard deviation, which is here. And let's display what this shows. Oh, okay. There's also the sequence log. So let me do this. Let me first show you the advantages. Then I do this in the second block. Let me run this. Okay. So we had these rewards. The advantage is just this, like the implementation of the equation. And for each rollout, these are the rewards. You can immediately notice some things. So the advantages are negative for the ones that were 0, and it is positive for the ones which were non-zero. This is purely a fallout just from this equation itself, right? Because we are subtracting the mean. So all of the zero rewards will become negative right here. And the positive ones, depending on what the mean is, will get some other value. But the ones which were zero will immediately be negative just because of subtracting the mean term from here. That's why you see all of these ones are negative, and then also similarly these ones are negative. So these are the advantages for each. Okay, before I explain this log prob, let's go over these two. Here, build mask, all I'm doing is, I think, and this was the question which was asked. Are we computing the log probs only for the assistant and not the user? The answer is yes, because that is what we are considering as our action space. So what this is saying is, only if it is the assistant role, I will consider that to be a proper label. Otherwise, for everything, for the system role, for the user role, in some models, there's a tool role. For all of those, my label will be -100, which is essentially the masking term here. So this is the build masked is doing exactly that. If we do a full rollout, you will see that only the assistant tokens will get non-negative 100, and the other ones will just be masked out. Okay, sequence loop. Now, similarly here, what I'm doing is I want to get the log probs for the messages, right? So how do I get the log probs for the messages? First of all, in this message, I build out the mask. I invoke this function to identify what were the IDs and the labels for each of them. Here, these two lines are just converting it into tensors with some with whatever. If it was a -100, then I say that this should be a 0, otherwise it is a 1. There's a term here that you'll often see, and maybe if you have done SFT, where we do a off by 1 adjustment. This is because, let's say, if you have a context length of n, you want to consider the n-1 for predicting the next token. So this is why there is an adjustment with either like in some cases starting from, if it is a target, then you start from the second. Otherwise, for computing the logits, you ignore the last term. But yeah, you have passed this entire thing through the model, which will give you the logits. And then once you have the logits, you do a torch.log softmax. This is in order to get to pass it through the softmax function and then get the log of it. So you end up getting the log probability for each token. And for each token, after you get the log probability, our objective is to get the mean of those. So which is defined by this term here, essentially multiplying the log probability with the mask term. So only the assistant ones contribute to the final log prob, and divided by how many of the tokens were actually there. So that's a whole mouthful, but effectively what these two are doing is it is giving you what is the log probability coming out from this term, and it is also telling you how many terms or how many tokens actually contributed to it. So we will see that. So I have run that, and I will now try to run it on this group. Let's see. So for each item in the group, I have passed it through my log prob, and I will get just the first term to see how many tokens were contributing. Okay. So the advantages now are coming from here. We already discussed this. And for each of the rollouts, we now know, okay, it had a reward of 0. The advantage we already computed. And how many of the supervised tokens from the agent contributed to this particular rollout. That is what I'm listing down here. Okay, now having this information where we have the advantage and we have computed the log probe also, we can now do one step of training. So let's go over this for loop. So I'm taking each rollout and the corresponding advantage term. For the rollout, I'm getting the log probe over the tokens. I'm multiplying the advantage with the log probe divided by the group to finally get the mean. This will give me the loss term. This is just a plain vanilla, like the reinforcement algorithm. And then we do a loss dot backward and getting the final loss just for show and tell purposes. After we have, so here I'm taking just one example. So you can say that my batch size is equal to 1 in this case. My group size is equal to 8. I will take one step of the optimizer and then I will see what were the final log probes before taking my step and after taking one step of the optimizer. So let's run this. Okay. Yeah. So intuitively we can start seeing what happened, right? So there were two terms here which were creating the patch. This was creating a patch and this guy was creating a patch, the row number 2 and row number 7. All the others were 0, right? So their advantages were also negative. If we look at the log probability before and after, they have kind of been pushed downwards. So the delta in this case is showing up as negatives, right? And for the ones which did contribute a patch with a non-zero reward, in this case, the log probes are coming out to be exactly 0. In this case, it is almost close to 0. But if you do a ranking of this, I would say this and this are proving to be useful, and the others are vastly negative. So they will be pushed down even more in the optimization process. Yeah, so essentially this covers a scenario where we have now taken the entire training data set using a batch size of 1 because there was only one data example or data point that we have been working through. We have rolled it out 8 times, collected all the assistant tokens, all the rewards. And using this information, we have taken one step of GRP. After this, the model will now have to be pushed back to VLLM because coming back to this diagram here, we have done all of this. We have computed the rewards, we computed the trajectories, which were the rollouts, we got the rewards, we did the grouped advantage calculation, we did one step of the GRP update. And now this updated checkpoint will have to be pushed into VLLM for starting the next round of training. Are there any questions? Is everything clear? Otherwise, we will take a break. And then once we come back from the break, I will answer the question exactly that Samantha asked. We will go into a lot more curves that we actually inspect when doing proper RL training to see if things are going wrong. Did you use the Oracle rollout for demonstration only? Yes, I used the Oracle only for demonstration purposes because I'm running this live notebook and you never know when you might get all zeros. Actually, let me highlight an important point there. If I did not use the Oracle and all of these rollouts did not create any patch, because this is like a live notebook, I have not hard coded anything. There's no random number or anything or seed that I have put in. It's possible that none of these created a patch, and then all of the rewards would have been zero. And then it would have been impossible for me to show you how advantage is done or how we are computing any log probes or something. So that is why this last one, I intentionally added the Oracle rollout. But this, of course, this is not done in practice. In a real world setting, I don't even have an Oracle. This highlights an important point, though. In realistic settings with sparse rewards, it's very, very common to get these kinds of groups which are all zero, and this is essentially wasted. This is what I call is a degenerate group. I have made a mention of this here because every or this can also happen if all of them are ones, because if all of them are ones, even then it's the same concept. There is no like difference amongst the rollouts that I can use for computing any kind of difference between them, at least from this particular formalism. And then I will have to throw it out, and it just leads to wasted compute that I wasted in producing the rollouts.
Okay, maybe we can take a 5 minute break or something, and then
Yeah.
I think you have planned a phase two also, right?
Yes, yes. I have planned a phase two as well. So we'll
Okay,
take a 5 minutes break and then we'll come back and then we'll start looking at some actual curves from real world settings.
sure, sure. Till that time, if anyone has any doubts, please post them in the chat so that we can take a look
Yeah.
at it once we are back.
Career advice. Yeah, you can always contact me. Maybe not in the chat unless you want everyone to see your question. I'm happy to do that as well. But I'll also share my email and yeah.
We'll take
Five
a
minutes.
5 minute of break, Shriharsha. Instead of, yeah.
Cool.
Abhishek, I've made you the host now. I'll have to leave in 2 minutes. You can continue the rest of the lecture if that's fine.
Okay. Okay. Yeah, that's fine. Yeah. Okay, I see some questions. I'll try to answer them. You can answer in the chat with a yes once many of you guys are back. CIOs are concerned of late with spiraling token costs. With this SWE agent mechanism, do we have a business case? Token cost savings number with a custom built SWE agent versus using frontier models. What's the order of savings we are talking about annually? Any benchmarks done that you may know? Sita, yes, your question is quite valid. What you can do is the business case is to have your own model in-house if you don't want to use frontier models. In which case you can take any of the off-the-shelf open source models. Let's say you take a Quen model or a Kimi, which was released recently, and then you host it yourself and in your within your business or within your company, and then you use that. So all you will have to do in that case is you can use in so for chat who are people who are coming back from the break, what Sita is essentially asking is this. So you are essentially using this, right? And for frontier models, all you are using is Opus or Fable or GPT 5.4, Soul or something as your model. And this is where you are spending all of your tokens. If you can replace this with open source model that you host yourself, the harness could be anything. The harness could be Cloud Code, it could be Copilot, GitHub Copilot, it could be Codex from OpenAI, because harnesses are agnostic of the model itself. So if you hook up your harness with a model that you have deployed, then essentially you have saved all the money. You don't even have to go to a frontier model. In terms of benchmarks, you can figure out how much money you're spending by sending to a frontier model, and you'll drive it down to zero at the end of the day. Okay, I'll go over the questions one by one. I have a question regarding long horizon agents. As agent trajectories become hundreds of tool calls long, do you think our biggest bottleneck is optimization, memory, or environment design? I think the biggest problem comes out to be context length, actually. So I think in your framing, it will be the memory. Because environment design is tractable. I can have any number of Docker environments. Uh, I can have proper engineering practices to orchestrate all of that. Optimization is also not a big bottleneck, honestly, because you have lots and lots of GPUs. You can do sharding across GPUs to do the optimization. The problem becomes memory because when the context length grows, your the the memory consumption from the activations go up like quadratically if you depending on what kind of attention mechanism you use. And that is why newer and newer architectures are coming up with uh, kernels which are specific for linear attention. If you yeah, and these are all in order to drive the context length down, to drive the memory down, because the memory a GPU has is constrained. Like H100s, H200s, they will have 80 GB, B200s will have slightly more, but you cannot go to infinite context length for driving this. So yeah, that's a good question. For all of these, memory becomes a big bottleneck, and that is what, if you read some of the papers related to even Kimi 3, which came out recently, they are focusing a lot on the memory in order to drive that down. Okay, Sita, developers in my firm are shocked to see the gap on usage of Claude. The SWE agent will to see the cap on. I don't understand this question. Developers are shocked to see the cap on usage of Claude. I'm not sure what you mean by cap. You mentioned that labs are now focused on joint optimization of both model and harness instead of model. Yes. How does that work? For example, do they do RL with both model rollout plus giving the model tools to spin up sub-agents or model deciding? Yeah, that's a good question. Yeah, labs are focused on both. They are improving the model. The model or the policy is where the optimization of the learning weights happen. That is where RL algorithms are coming into play. At the same time, they are also improving the harness with things like support for subagents, support for compaction, support for multimodality, where it is not just about text, it is also about how to handle images and things like that. And those are improvements in the harness. So there is joint improvements in both the model and also the harness. And that is why you see a lot of improvement in the benchmarks. The benchmarks are not just improvements on the model itself. They are also because of the improvement on the harness side. Now, there are some benchmarks where they fix the harness. They say that we will not allow you to change the harness. The harness is something that we will give you. You only give us the model and then we will evaluate it. So those are pure benchmarks where you can track improvement on the modeling side of the world by keeping the harness fixed. But in a realistic setting, especially with frontier labs where they just care about the end user experience, you need to improve both. You need to improve the model and also the harness. Hopefully that answers the question by Srihara. Thurvil Shah, can you give us some idea on reward model designing for subjective tasks like make a beautiful website? Yeah, yeah, those kinds of subjective tasks are very hard. I have worked in those kinds of scenarios also. You end up having to go to LLM as a judge. So you, for example, make a beautiful smile. You give it to a judge and hope that the judge is, for the judge, you ask him to grade, right? You say, give me a grade of 1 under so and so conditions, give me a grade of 10 if it satisfies so and so conditions. And then you have some of these criteria and you rely on LLM as a judge. So it is subjective in nature. It's very hard to have executable rewards in those cases. I'm going to the next question. Natarajan, are reasoning traces and tool call outputs maintained across multiple turns during rollout? Yes. So reasoning traces and tool call outputs are all maintained, and that is exactly what we are going to see next. The reasoning traces will help you to observe what the model was thinking before it made the suggestion that, hey, run this particular tool call. In fact, your learning will happen over those reasoning traces from the model as well, because it is not just important for the model to suggest the right tool call, it is also important for the model to reason properly before suggesting that tool call. Hence, reasoning traces are important. As far as tool call outputs, yes, tool call outputs are essentially the observation outputs. Those are maintained, but those are not contributing to the log probability or to the final optimization objective. Cap as in the, okay, this was for the previous question, I think. Cap on the usage of Claude. Cap as in the number of tokens per, oh yeah. So there is a cap on Claude Code because yeah, many companies blew out their budgets. Yeah, I've heard about that. Yeah, if you build an in-house custom SWE, of course, yeah, then you don't even have to go to the frontier models. There's a question. It has been a chicken and egg to get the job. And we understand theory and have done some lightweight projects. Yeah, I know. Since it's very, yeah, I know. Generally big companies, but companies. Yeah, this is a very tricky thing actually that Srihara you're asking. Personally, what I have found Visuara courses to be quite useful in building up the know-how because in those cases you can run through some of the stuff without even using GPUs or using like T4 GPU instances like what I am doing in this talk. In general, I have also found Sebastian Rushka's books to be quite useful because you can run through them even on a CPU. The most important thing is to have the conceptual clarity on, for example, how is attention implemented? How are all these things playing a role? What is harness? What is policy? You don't need GPU to run the scale of experiments at this point till you actually land a job, I would say, because at least till job interviews, the most important thing is to have the concepts clear. Hopefully that answers the question. How do we tread this? I would say, yeah, the two main resources in my mind are Sebastian Rushka. He has two books. One is called Building LLM from Scratch. The second one came out very recently, Building Reasoning LLM from Scratch. Those two are very useful, those two books, and then Visuara courses, of course. Yeah. For me, Visuara, I have taken several Visuara courses and they have been very useful. Are projects important now that we can use agents to do all the executions? Well, you tell me. If you go to an interview, I hope they'll let you use Claude to answer your interview questions. I think projects are very important. Till you do projects, you'll not understand what is going on. And do those like small scale projects. You don't have to do very big GPU intensive projects. As foundation models continue to improve, where do you see RL becoming critical in real world? Most frontier models are closed source, so it's not very clear where companies are actually applying RL beyond the initial model training. Well, it goes to a fundamental point, right? It's not very clear where companies are actually applying RL beyond the initial model training. Well, if you're a company and you completely rely on frontier models, yeah, there's like leading to all of these problems where you can get maxed out of tokens and spending budgets. So at some point of time, I think that's the whole promise of open source models. And even within open source models, there's a lot of room to fine tune them for your specific purpose. Uh, but I'd leave it to companies to decide where they use RL. Thurville is asking, what are your thoughts on the approach on the trending workflow mode where orchestrator breaks complex tasks into smaller tasks and spawns sub-agents? Oh yeah, I mean, agent-to-agent interaction, sub-agents, collective intelligence, all of these are, yeah, emerging fields in this space. RL is going to play a role there also because SFT is not going to solve these problems. And then it becomes a question of the harness. How is the harness going to orchestrate all of these sub-agents as part of the learning process? Because then it's no longer a simple loop like what I have shown in this diagram here. It will be the harness which is doing the orchestration over multiple sub-agents where sub-agents could be interacting with each other for for their learning objective. Can we fine-tune open models like Gemma, I think, Gemma 4 with enterprise data to make it useful? Oh no, for your own enterprise data, you should use open models like Gemma 4. I think I tried Gemma 4 a bit. I found it a bit tricky because there were some kernels are missing, and yeah, it's the open source community has not caught up to it yet, I think. But you should certainly start with that. You should not do something from scratch. Pre-training, yeah, forget about pre-training. We are also saying in the all frontier cutting costs on their model. It would be good to see a trend here. Yeah, I think, yeah, open weights models, there has been a push. I think they are here to stay. There will always be a world for open weight models. Well, the question is how much investment do these companies make in open weight models, right? So that is a question that only the companies will be able to answer. Cool. Did I miss any question? Did I cover all of them, or we go ahead? Can you guys reply yes if we can move forward? Cool. Cool. Okay. One graduated from the same university a long time ago. I graduated a long time ago. Okay. So look at uh, let's look at some curves, maybe how we do training. So of course, the example I gave you was a very small handcrafted example. I took only one sample and ran a bunch of rollouts. I got the rewards and then I took one step of GRPO. So here, what am I showing you? I'm showing you typical reward curves that someone who is doing RL in these labs will look at, and how they kind of start diagnosing issues there and all of that. So first of all, as you are doing this kind of training, one thing that you will certainly want to track is the training reward, right? So here I took two runs, and these are realistic runs. So these are not fake runs. We will go and look inside the trajectories also. You can kind of do these runs by taking a Quen model yourself and using a framework like VERL, for example, for doing your training, or something like SkyRL, PrimeRL. These are different kinds of frameworks for that you can do. You can select a simple data set, just like SWE-Bench verified. Many of these frameworks already plot these curves for you. So one of the most important things that you want to look for is how are your training rewards trending? In this case, I am showing you two plots. One is this plot here, which started, let me expand it. So this line here is using Quen 3 14 billion. And the blue line here is using the Quen 3.59 billion. So if you see the Quen model, the Quen 3, which came out, I think, last year, it started with a very low uh, training reward. And then as it progressed through multiple steps of RL training, things started improving, and this is essentially a good sign. Same thing for Quen 3.5. You see Quen 3.5 has a much higher base compared to Quen 3 14 billion. So this is kind of an indicator that the Quen 3.5 is a much stronger base model already. And you can also see in benchmarks that they have published that it's Quen 3.5 is much, much better compared to Quen 3 14 billion, and the reward curves go up. So I would say always look at training rewards to see how your jobs are going. And this is essentially something that for someone working in the field, it's similar to if you're doing SFT. And in SFT, okay, can chat answer this question? Okay, can chat answer this question? When you are doing a run which uses SFT, what is the most important curve that you look at to validate that your training is going smoothly? Correct, correct. So because yeah, training and validation loss, you need to look at both, yeah, because training loss by definition should go down, because in training loss, the objective is to minimize next token prediction. If your training loss itself is not going down and it has spiked up, it means that you have crossed the global minima and something really, really bad is happening. So there's no point continuing that run anymore because it has started diverging from that point onwards. Validation loss will kind of tell you whether you have hit like overfitting issues in training, and hence your validation will start going up. But fundamentally in SFT, loss is the most important because SFT is trying to minimize the loss, specifically the next token prediction loss. In this case, in the case of RL, the most important one to look for is how are your rewards trending? Because at the end of the day, that is what you are kind of optimizing for. Uh, I wanted, and here also there's a concept of training rewards and validation rewards. If you hook up your RL run with some validation data, you can also start seeing whether training is helping you on the validation side of the world also. In this specific plot, you will see that this run actually crashed at step 139, and then I restarted it, and hence it is kind of a continuation. And surprisingly, there is a small jump that happened at this point of time. These are like some realistic things that happen in real world training scenarios. And then it crashed again at this point, and I restarted it, but this time it started with a lower pace. But these are maybe artifacts of different data batches that it started off with when I restarted the run. The blue line, on the other hand, did not encounter any crash, and it was safe. Okay, so this is one of the things. You will end up having to look at a lot more other plots as well. An important one is what is the log prob plot? Specifically, what is the log prob difference? Let me focus on this a bit as well. Try to smoothen it out. Yeah, so the log prob absolute difference is also an interesting plot to look at. What it tells you is going back to our thing here, right? Okay, close. So if you recall, I mentioned that in our RL loop, we have log probes which are coming from VLLM as a part of driving this. At the time of doing an update also, because we are passing all of the tokens through through the optimizer, you also get log probes from here. And technically, the log probes coming from VLLM should be very, very similar to the log probes coming from this part of the optimization step. Sometimes that is not the case, specifically if there has been a policy drift between this and this. There are multiple papers which talk about a train inference mismatch. You can look up some papers that talk about this for RL training. For example, diagnosing training inference mismatch in LLM reinforcement learning. And here they talk about problems where, for example, if you look at this, if you look at this orange line, the training reward went up, but when they started using VLLM, things started crashing. Why these problems happen? Because you are using VLLM for driving the rollouts, and then you are using some other framework, in this case, VE exact, or you could be using Whirl or something like that for doing the RL optimization step. And this leads to problems in the training and inference mismatch. Looking at log probes, absolute difference is one way to solve. Ideally, the number should all be 0, right? Because there should be no variation between training and inference, specifically in off policy on policy GRPU. But as long as it doesn't blow up, this is good enough. So these are some interesting plots to look at. What are other ways to debug RL runs? Okay, what would be the reason for the crash? Avinash, that's a good question. I think that's where most of my day job goes into figuring out, like, why do jobs crash? There could be like multiple reasons, uh, starting from bugs in the optimization code, bugs in context length, just system issues, uh, model sharding, VLLM, all these different libraries that we use. And yeah, I mean, that's bread and butter of being an engineer or like a software engineer, right? Like things will go wrong and you have to go and figure out what is going on. There was a question earlier about do we track reasoning and tool call observations? I wanted to cover that also as a part of debugging. Okay, so this is one example I wanted to show you of. I have told you so far that we will do a lot of these rollouts, and in the notebook I gave you one example of what a rollout looks like. In the real world, this is what a rollout looks like. Let me go over it one by one. And I think this will also show examples of what we keep as part of the rollout. The first is the system prompt itself. We have already seen a small version of it. Can you please zoom in? Yeah, sure. This is good. But it does lead to, it's okay, I can cover it. Okay. Yeah, but I don't see the slider at the bottom anymore. Maybe it's an edge issue, but that's okay. This is what an entire rollout looks like. I can randomly pick any sample here to inspect. These are some internal tools that we have just for looking at rollouts. Not too different from what I showed in the notebook, but I just wanted to show what a real world rollout looks like. The first is the prompt. This is the system message. We have already seen it. The system message tells you you are a helpful assistant. It gives a description of the tools. Earlier in the chat, people have already mentioned that you can embed tools inside the system message. This is an example of that. Here, I've only defined bash as the tool available to you. And then I have said, execute a bash command, and then you can specify these things as parameters. Blah, blah, blah. So this is the entire system prompt. I'll also show you what is the problem that they were trying to solve here. Okay, So the problem is this, someone has given some issue description. I think it is coming from NumPy, the NumPy repo. Structured D types do not display field information in array representation. When creating a NumPy array with the array's representation does not display, blah, blah. And they have given what is the expected behavior, what is the actual behavior. And this was the issue description. This is exactly similar to what we saw in our constructed example also. Now comes the different turns. So the assistant turn, someone was mentioning, do we keep reasoning also? Yes, we do keep reasoning. This is the assistant's reasoning, or as they call like the thinking block, whatever is happening inside thinking. The assistant is, first of all, printing out its reasoning trace. Okay, let's see, I need to fix something. First, I should check which files. I will start by using the find command. And then he's suggesting that he should use bash and he should use the find command. This is the first part of the trace. Now the harness takes this information, it parses this part, and sends it to the environment, right? So the policy, it gave all of its reasoning traces, told it something to the harness. Now the harness passes it to the environment. The environment ran that find command, and what did it returned some observation. So the observation is this. This is, I think, what I had already mentioned, that it, first of all, it gives a return code. In some cases, it gives a warning, the output of the observation. If it is too long, it's also a problem. But yeah, it did a find. As you know, in bash, find command is to find all of these different files which follow this pattern. So it is listing all the stuff that it found out. Look at how big the observation is in this case. Okay, so it sent all of this observation back. Now the harness will intercept this observation. It will feed it to the policy. The policy will think about it. Let's see what it has thought about it. What has it thought? It has, in its thought or its thinking part, it said, okay, found a directory called something. That's part of the NumPy package. Let me check the files there. And then he says, okay, in order to do this, I need to run the ls command. Now, the model is wanting to run this ls command. The harness intercepts it. The harness intercepts it and then sends it to the environment, and the environment.run. Again, then it runs in the environment, it gets the observation back. What observation do we get back? Okay, you were successfully able to run ls. This is all the output that we got, and sends it back to the assistant. This goes on and on and on. Okay. At the end, he thinks that maybe I'm able to get to a final, yeah. So at the end, he thinks, okay, maybe I'm able to solve the problem. And he suggests that this is the final patch that will solve the user's issue. With this thing, we send it to the verifier. The verifier will now superimpose this patch onto a cleaned version of the container. It will run the test cases. Here you can see it is running all of these different test cases. And at the end, if all the test cases pass, it will get a reward of 1. Otherwise, it will get a reward of 0 or something. In this case, it seems that the patch is correct, and hence it got a reward of 1. In other cases where, let's say this one, where maybe it was not able to produce a patch at the end, or maybe it produced a patch, but clearly this patch is incorrect. Hence, it only got almost a 0. Because it did produce a patch, I gave it a reward of 0.05, or I could have also said that, okay, I will give you a reward of 0. So this is essentially how, when you do runs like this with RL and multiple iterations, multiple loops, you want to take a look at all of the different trajectories to see what is going wrong, and then how rewards are being given to each of the stages. Uh, and hopefully that will help you debug some of these. I'll try to, I'll take some questions. Do real systems crash randomly during training? Yeah, of course. Like it could be a out of memory issue. It could be anything because uh, you are doing things in batches. You want to look at, in this case, it's not related to memory. So you want to have different kinds of plots to see what is your GPU memory, what is your GPU consumption, all those kinds of things that you can also track to see how much memory. But this, in this case, this crash is not this is something else. Which tools command agent uses to fix the code? How does it know what code change it needs to make? Yeah, Birendra, the point is, as the agent, look at this, right? Come back to this, come back to this diagram. As as the as this agent is getting more and more information about the environment and trying out different things, it learns about the environment. It is taking an action and getting an observation and using that observation to determine what is the next action. So that is the whole point of in how does it know what code change it needs to make? So that is part of the, I'd say, the trial and error process of reinforcement learning. The whole process of reinforcement learning is that you have a certain policy. The policy or the base model has a certain capacity. It has to interact with the environment. Sometimes it takes random actions, right? So there is explore, and then there is also exploit. And you do it with a certain I'd say at a certain ratio. In some cases, it could be completely random tools or actions that it takes. But once you have built up enough information saying, okay, I ran a LS, then I ran a cat. Oh, now I think I have got the right information. That is how it builds up its intuition. And the whole point of RL is by having all of these multiple rollouts, where some rollouts end up giving you a 0 and some rollouts end up giving you a 1, the training loop knows that, oh, the rollouts which gave you a 1 as a reward are the useful ones. So try to push the tokens in that direction. The the tokens or the rollouts which helped you get a 1, those are the ones which are valuable. And that is what this GRPO or the learning loop will try to update into its policy. And hence, increasingly, by looking at data, by taking multiple actions over multiple batches, it starts learning to know what is the right thing to do. I hope it answers the question. Yeah, Sri Harsha is answering that question. The agent uses bash tool with the cat command to update code in the file. Yeah. So in this case, I have given him the cat command. Uh, so it can use that. In other cases, I can give it an explicit tool called write file, and it can use that tool to write to a file. So it depends on how you have defined your tools in your learning setup. Natarajan, I wonder how to design reward models to recognize some of the bad strategies. To design. Yeah, how do you design reward models to recognize some of the bad trajectories is because of tool failure? Yeah, you have to define tool failure. So what is tool failure? The agent could be doing everything correctly, right? It has invoked the right tool, but the right tool with the right parameters and everything failed in the environment. Now, that indicates it's a problem with the environment because everything being correct, tool failure, if the agent has passed the incorrect parameter to the tool, then it should be penalized for doing that. Then we cannot say that the agent did everything correctly. On the other hand, if the environment is corrupted or something and the tool doesn't execute and then there's a tool failure, that's a completely separate artifact altogether. Okay, tool failure is a timeout or a bug. Yeah, so in cases, yeah, that's a good point. So in cases where tool failures are timeout or bugs, then yes, we have to be careful how do we shape our reward in those cases. Because the agent is doing everything correctly, but there was a timeout, which means it should get some reward for the things that it did so far, right? It didn't get to the right patch, but at least it did something. So then what we can do is, and this is often done in practice, we see what is all the stuff that you did so far. Someone is trying to enter the room. I think I will not allow him. Yeah, so you take a look at what he has done so far before the timeout, and he didn't get to a patch, but can you see, like you can take a diff and then you can see, did he touch the right files? Did he touch the area of the code where the correct thing should be? Because as a verifier who is attributing a reward to the work done so far, you have access. The verifier has access to the test and the correct patch and everything, right? So you can, yeah, that is where reward shaping comes in. That's a good question, Natraj. Yeah. Which RL framework do you typically use? And also for this project. For this specific project, we are using a fork of Whirl. Whirl is a popular framework. There are other frameworks like Prime RL that you can also use. Those are much simpler. Do you typically bootstrap the models with SFT and then do RL? That's a good question, Sri Harsha. It depends on what is the base model that you have chosen and the task that you are doing. In some cases, if you have chosen a base model where the base model is not doing good in the task, right, right, with just the off-the-shelf model, then you do have to do SFT because SFT has generally shown to be the step where the model starts to know about at least some bit of the action space that it should work in. If it doesn't even know anything about the action space, then going from base model directly to RL has shown to be not that useful because RL can go haywire in just trying to figure out the action and the tool space and it becomes very hard to converge or things of that sort. So in such cases, SFT is critical, is important. Having said that, recent models are base models are already very, very strong. If the base model is very strong, then you can just take it and do RL on top of it to see where you are. But generally, SFT is a recommended step to do before RL. Can you please give us insight into what happens when an RL policy is deployed with regards to observability and the metrics to monitor? Yeah, Shiva. Yeah. So when a RL policy is deployed, I would say it is no different than any other model that you have deployed. Because at the end of the day, what is a model that you have deployed? A model is purely stateless, right? A model gets some input, it goes through the model stack, and then it generates tokens as output. It is I mean, for any autoregressive like LLM and that sort of thing. Similarly, even for something like a classification problem or whatever, where if it just produces a classification result, but you still want to log all of that information uh, into some sort of a backend system. And most companies do that because all of this eventually becomes traces that you can finally use to even improve the model later on. What do you think Anthropic and OpenAI and these companies are doing? So they are getting all the traces, they are logging all of it. And I'm pretty sure behind the scenes, they are looking at all of these rollouts, trajectories, and using it to improve and fine-tune their models behind. So yeah, you should certainly try to log as much information as possible uh, after you have deployed a model, not just the RL model, but any model. Yeah. How can we know whether RL training progress is hindered because of reward shaping issue versus model size? Yeah, versus better algorithm like Echo. There is no silver bullet to it, honestly. Uh, you just have to try different things. You have to try um, larger model families, better data sets, uh, yeah, better algorithms like Echo. There is no silver bullet on what is hindering RL training progress. In fact, you'll see my name in the acknowledgement section of Echo, the Echo paper, uh, like that came out from here, from MSR, from our team recently. I would say it was purely almost like a side project. Okay. Like the author, she was trying out different things. And then at one point of time, she realized that, okay, if you plug in this particular loss, it starts to be helpful. And then that was the motivation for the work. So it's a matter of trying out different things, trying to get some sort of an insight into why something is not working, how it could be done better, either through reward shaping, better data, better algorithm, whether it scales with different model sizes and all that sort of stuff. Cool. I think it has been a very interactive and good lecture. I have certainly enjoyed a lot of the questions. It also has given me a lot of room for thought on how I can maybe explain things a bit better. But yeah, we can stop it at this point of time. Cool. Any other questions? Cool. I'll put my email address, or you can even get it from, I don't know how to. In case you want to reach out to me, you can send me an email. Cool. Thank you. Thanks, everyone. Have a nice weekend. Hopefully, you guys learned something. And I'll paste this repo once again. There's also a file that personally, I don't like notebooks too much. It doesn't help me put debug and breakpoints. You can also use this file here. You can just put a breakpoint and just run it and see each of the small individual steps, specifically the GRPO step and how optimizations happen. I will paste it once again. Cool. Thank you, everyone. Bye-bye. My LinkedIn. LinkedIn, let's see. I don't use LinkedIn that much, but I do have it. Okay. Thank you. Bye-bye.